Yeah, I started record. Hello, everyone. Thank you for joining, and I think more people will come who missed. It's not a problem. I will upload record to the broadcast channel, and please keep off. And during the talk, if someone will be noisy, I will try to mute proactively. And today we have an interesting topic. We will talk about data lake and data warehouse. And Jared will be sharing what solution architectures are best suited for the role. Okay. I just mute some people. Yeah, he will be shared what solution architectures are best suited for the roles of the various types of organizational needs and how those two approaches can complement one another. Jared listed as one of the top marketing operations leaders you should know in 2018, and also he's a practice director in Intracity. He can tell more about himself. Jared, you can take the word.
Yep.
Please.
Okay. Sounds good. Well, good day, everybody. I have a bit of a change in title. I'm now the Vice President of Emerging Technologies. So I run that side of Intracity. I'll give you a little bit of perspective on who Intracity is and what we've been doing. So Intracity is a company that that focuses on turning data, raw data, into information through consulting, right? So we go into lots of different kinds of companies, both multi-billion-dollar companies as well as smaller organizations as well, and helping them figure out how they're going to deal with the problem of turning data, which is raw data, and turning it into actual information that they can take action on. And that's what we do day in and day out.
Jared, someone mute you. Can you try to unmute you? Or I will try. I can. Okay.
Okay, I'm unmuted.
Yeah, good.
Am I unmuted?
Yeah, I can hear you.
Yeah, no sweat. So over the last, about 6 or 7 years, what I did is I decided to, in these consulting engagements that we were doing, we kept getting, either, people wouldn't understand certain concepts or they wouldn't quite grasp something that we were talking about. And this kind of kept happening, because it's just a natural part of doing consulting. You have to kind of educate everybody about what's happening. And one of these times we had a proposal on the table, and we were talking with the CFO, and everybody was on board except for him. And we couldn't quite figure out why. And we went to meet with him, and he goes, Jared, I'm excited about this project because everybody else on my team is excited, but I don't even know what a data warehouse is. And so, of course, we explained it all to him, but after we left the meeting, I'm like, I can do something about this. So that's what we started, this YouTube channel about 6 or 7 years ago. And we started explaining just some of the most basic things about the data, the behavior of data, turning it into information, and a variety of topics. What is a data warehouse? What is business intelligence? What is big data? What is Hadoop? What is, what is cloud storage? What is data governance? What is data quality, master data management, et cetera, et cetera, et cetera, et cetera. So we've built a ton of these videos. There's probably about 60 to 70 videos at this point. I actually haven't been back to count, but if you see down on the bottom left there, you'll see where our YouTube channel is, and we do get a lot of exposure to different organizations just based on that video. They end up wanting to talk with us, and we start doing projects that way. One of the things I've learned in this process of making these videos and sort of trying to simplify this story of what is turning data into information, I've come to realize that this process of turning data into information is actually a very human experience. You know, it's part of our human story. And I've started to realize this, and it's gotten me interested in the realm of psychology. And there's a gentleman by the name of Jordan Peterson who's become very popular these days, but his early work, or you know, before people really knew him, he was doing a lot of work with Silicon Valley to try and help startups identify the ideal types of leaders to lead their organizations or to become CEOs of these startups. And what he used is the big 5 character traits. And these big 5 character traits, I'm not going to dive into that whole topic, but there's 2 that seem to have good indicators on whether someone will be a good leader of either a startup or a good leader of an established organization. And these 2 are openness and orderliness. Sometimes the orderliness is called conscientiousness. And on the openness side, people that are high in openness tend to be, you know, really interested in new ideas, really interested in what's novel, and they like art and music and just basically new concepts, and are always trying to sort of feed new information. And so people that are very high in openness tend to be good CEOs of startups. And so, but on the other hand, on the orderliness side, orderliness is the tendency to be, you know, super high in process orientation, really thinking deeply about a process, being super dependable, you know, showing discipline. All of those traits are very focused on the orderliness side of the equation. And not surprisingly, CEOs of orderly organizations tend to be, or CEOs of large organizations tend to be high in orderliness. And if you look at the examples of the people that I provided, so for example, you take Brian Chesky. I mean, if you read about Airbnb's sort of growth into becoming what they are today, it's a very creative story, and it was definitely not handed to them on a silver platter. I mean, they had to struggle for it. But Brian Chesky, the way he tried to get buzz around Airbnb was actually very funny. It was during the 2008 election, and so he and his startup partner, they created these cereal boxes. Obama O's and Captain McCain's, and he sent these cereal boxes to a bunch of bloggers and people that were interested in doing startups. And so very, very creative, very out of the box thinking type stuff. Jack Welch, on the other hand, if you know his story, he comes from General Electric. General Electric was sort of in a state of mediocrity when he took over. And he basically completely changed General Electric. He got them to focus in on the processes that they were running and get rid of all of the waste in those processes and really hone in on being successful in that domain. And it completely changed General Electric. So what you can see is that there are possible downsides, right? If you're really, really heavy in the orderliness side of the equation, and you're really light in the openness side, then you're probably not going to be aware of, you know, of new information, new ideas, right? So it's very easy to topple a very process-oriented organization with new innovations, right? Because organizations that are heavy into sort of a focused process, they're not paying attention to any new information. And the same is true for individuals. People that are super, super high in orderliness, they don't do well with adding new information. They don't take in new information very well. The same is true on the other side. There's downsides to being too open. You could be so open that your life is just chaos, and there's just no order in your life, right? And the same is for an organization. The organization could be so open that they're unable to actually focus on a direction that will take them towards profitability. I've had to deal with this because I work with a lot of partnering technologies at Intricity. And there's a lot of folks that would like to partner with us, but I have to be focused enough that I could say, you know, I can't partner with everybody. I have to focus on a direction. And so the obvious question is, well, what the heck does this have to do with data? And it turns out that the concept of openness and orderliness tie really, really well to the concept of a data lake and the concept of a data warehouse. So there's a lot of people on the phone today, so I'll give you kind of a quick description of what a data lake is and a data warehouse is. So the data lake is a location which allows me to put the data easily. I can add data super, super easy. So the data lake emerged from the concept of schema on read, which allows me to just put the data onto the file store, like S3, for example, and I don't have to worry about describing for the file store what exactly I'm putting in there. I can just load it without any concern. And so it's very open to new data. If I wanted to add some weather data on a whim, I could do it very, very easily. A data warehouse, on the other hand, focuses on conforming dimensions, conforming data so that it is visible by a human and is comprehensible to the organization, right? So it's not just raw data. I want to actually provide meaningful, conformed dimensions and measures to somebody, right? And that's a much more orderly type of activity that we're going to be jumping into. And so, as you can imagine, they have pluses and minuses, right? So in the early, I would say between 2002 to about 2007, the data warehouse reigned supreme. I mean, nobody, and I'm mostly talking about, and I'll go through this timeline a little bit, but those environments actually suffered quite a bit because new information was so difficult to add to the data warehouse because it was such a structured environment. And the tools weren't even available in the market to deal with data in an effective way outside of Excel. And so, to get information and to create new ideas, do R&D was a very difficult task. There was really no title for someone who was a data scientist because you just didn't have either the horsepower or the ability to get access to new data. And the same would be for the data lake. If there is no data warehouse and I'm just dealing with a data lake, I can't scale. Now, most people would not think of a data lake as something that can't scale because I can put infinite amounts of data into a data lake. The scalability problem is not in adding data. The scalability problem is in adding users and meaningful analytics, being able to distribute trusted analytics to a broad audience. That's very difficult to do if you're very low in orderliness, or very light in orderliness, I should say, to the slide. So some of you may not recognize this this reference. This is a reference to the Monty Python, the Quest for the Holy Grail, and I'm not going to try and explain it because I'm not going to do a skit for you. But if you don't know it, then watch the movie. But there's a part where this guy is trying to, drop someone off as a dead person, and the guy keeps saying he's not dead. And that's kind of what's been happening between the data lake and the data warehouse over the last 5 years. Is, we constantly get this, the data warehouse is going to be dead. And the timeline has kind of worked like this. Right around 2002 to 2007, data warehouse reigned supreme. We talked about that. But right around 2007, that's when the first iterations of Hadoop started coming out. And Hadoop, in its early incantations, very few people were really even paying attention to it. But as it started gaining some prominence, everybody started saying, wow, this is going to replace the data warehouse. The data warehouse is dead. This is technology from Google, so sort of this ivory tower idea that this future technology is going to just change everything. So that people really thought that this was the future, and people started talking about it as if they had deployments, you know, in their own environments of Hadoop. And this was what the reality was. And this was a quote by a Duke University professor. Big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everybody thinks everybody else is doing it, so everybody claims they're doing it. And that was the sentiment at the time, is that, and when this came out, it was hilarious because it was the truth. Everybody wanted to say they were using Hadoop. And it wasn't until a little later, 2012, 13, 14, and even 15, where you started seeing the concept of the data lake emerge. And when the data lake emerged, it was almost like someone gave a name to a Hadoop deployment in a corporate environment and said, hey, this is where you could put all your stuff. You could put all your data in here as a single target location where all the data could reside, and you don't have to go to 10 other different places. And all of a sudden, once it had a name, the data warehouse was going to be dead. We're going to kill the data warehouse. And so organizations approached it that way, right? So organizations bought into the idea that we're going to have this huge centralized store where we're going to have just directly dumping data into the store, and we'll query this store. And they did, and there were a ton of failures. And the reason why is because it was just a giant junkyard that they had created of databases and files and all sorts of content was sitting inside of this data lake. And even today, we say, well, the cloud is going to destroy the data warehouse, although not to such an extent, because people, I think, are starting to catch the idea that there's something to having data be in an orderly state that matters. And here's the issue. This is the problem. If I have a data lake and I have all of our data sitting in that data lake, the people that have the capacity to actually consume that data are the people that are willing to spend hours rummaging through data and trying to figure out how it all comes together. And so you have that crowd, and then you have the rest of the company. And some of those people, some of those managers have the time to rummage through data, but a lot of them don't. And so when management needs to make a serious decision and they're living in this world and they need to know what the truth is, they're stuck because they've got a lot of people that are trying to figure out what the truth is, and there's no conformity of the data. We have descriptions of what might be the right data, but we're not sure. And so you get, someone says, if the CEO says, I want to know what the truth is, and you've got 50 people out there that are, kind of assembling what they think the truth is at that very moment, and you roll that up, well, then I've got, a Tableau dashboard, I got some Excel spreadsheets, I got, maybe it's a quick view, maybe it's an Amazon QuickSight, whatever it is, I've got 30 of those, and that supposedly is the truth assembled by 50 people. That is not good enough for companies. They need to be able to feel confident of what the truth actually is. Now, this is a bonanza for BI vendors. They love this situation because they can say, hey, I can give you orderliness. I can help you have confidence in the truth. And their pitch is, put your logic, put this orderliness logic, the conformity logic, put it in our BI tool, and let us do the processing of conformity. And we will deal with the problems of how to assemble this data to simplify it for all your users. But there's a fly in the ointment, and the fly is that the visualization layer coupled with the logic layer in a SKU is a black box. It's owned by the vendor. So the question is, do you want to give all of your time and effort into a private tool that you can't use in other places? And here's some of the complaints that we normally get, that we normally see when people do this. So start from the top left. I need this data to run another application. So I'm not talking about BI. I need to take the logic that you've worked so hard to build into your BI layer and use it elsewhere effectively, scalably. Well, in a BI tool, that may not make so much sense. Another one, one of our partners needs a live data feed, actual data, not visualizations or anything. I need actual data. I want to write a SQL against this data environment. The other one is, why are our queries so slow? This is a really common one in data lake environments, because what the BI tool often is doing is having to go do this gnarly assembly of data, because all of that data is sort of jumbled together in a giant junkyard. The reason I highlighted the yellow one is it's so common. So a lot of BI vendors, to fix the problem of slow queries, they put everything in memory, all of it, whether you use it or not, and regardless of the size, it all goes into memory. Well, once that happens, all of a sudden the BI environment is tremendously expensive. And then the last one is, and this is ubiquitous across every organization. Wow, I found a shiny new BI tool. I want to give it a try. Well, guess what? All of your logic is locked into another BI tool, and you can't access that logic. So if you want to use a new shiny BI tool, then you've got to replicate that logic in your new shiny BI tool. So I believe, Intricity believes, that a much more healthy way to look at business intelligence and analytics is to think of it as decoration. Nothing more than decoration. If you think of it as decoration, well, when you think about decorating your house, you might change the decoration of your house fairly regularly, right? You might change the coffee table, put a new sofa in. You may repaint your house. That doesn't require you to change your plumbing or your electrical or change the studs, right? You're not having to change fundamentally the logic of the house to change the decoration. The problem is that in BI, we have the logic and the visualization in a tightly coupled relationship in a lot of BI deployments. So the goal of a data warehouse is actually to decouple this relationship so that now the visualization layer truly is decoration. And the plumbing, the electrical, the foundation, the roofing, et cetera, is in your data warehouse. The complexity is in your data warehouse. And this is what gives companies the confidence to invest in a data warehouse, because now I can go and select any number of BI tools. I don't have a commitment to one way of visualizing the data. I have a commitment to any number of ways of decorating my data, but the logic is consistent because I've already addressed that problem in my data warehouse. And so for organizations that really understand this problem, which is probably seriously 10% would be a big number. There's very few that actually get this, and they understand that logic should not be embedded or nested in a private tool. For those that realize it, they put a lot of money into the data warehousing side. And the BI side is a constantly evolving thing, changes all the time. So the question then is, okay, so Jared, how would you set it up? So I'm going to turn the lights on in the presentation, and we'll go through an architecture slide. And I'm not going to get into, super into the weeds, but I will dive into a couple of components here. So let me just do a quick harbor tour of the slide. So on the very left-hand side, you have data. In the very right-hand side, you have users. Okay, so the goal here is to turn data into information that users can consume. So everything in the middle is the sausage factory that we use to actually get that to occur. So the first step here is we need to have a mechanism to orchestrate the streaming of data to the cloud, okay? And off of these systems, off of, whatever on-premise system, whatever cloud system, whatever you've got, we need to be able to orchestrate the data's movement into the cloud. So doing that is actually pretty straightforward. There's technologies for streaming today that are very much out of the box, very much sort of click and you're out of and you're off to the races. You can start streaming fairly easily. S3 is a perfect place to have a data lake, in our opinion, because S3 provides us a very cheap storage mechanism. It allows us to query the environment, but it also has a lot of services I can put on top of it to run applications, to run data warehouses, and even to run analytics through Athena. And so, if from the data lake, we actually produce the data warehouse using an ELT transformation structure. So we'll actually we'll use either Snowflake or we'll use Redshift, one of those two, to actually create our data warehouse. I do tend to like Snowflake because of the way that they address the acquisition of data is very interesting. It allows for metadata pointers rather than actually moving the data. It stays in an S3 bucket and everything is an EC2 instance. And so you can run your ETL or ELT routines on that and not have any conflicts at all with however many EC2 instances you want to create for different functions. And then what we'll do is add a BI semantic layer. What is a BI semantic layer? Okay, so just let's think for a second how BI has evolved for a moment. In the old days, I had the luxury of having the BI layer right next to the data warehouse or whatever my data source was. So I could be really sloppy and going back and forth. I could send a ton of data to my BI layer and have it crunch stuff. And I could have, I could have queries kind of go very seamlessly between them. But now I might have a BI layer that's in, a server rack in Atlanta, and another one, and the data warehouse layer somewhere in, Nevada. So they're miles apart. So these days, I do not want to take the data to the query. I would rather take the query to the data, because a SQL query is just a few lines of code. Whereas pumping data out to go into an in-memory store is a very expensive thing to do if you're in a big data environment. Okay, a semantic layer allows me to create a host of SQL queries, many SQL queries in a model. And in that model, I define basically all my future SQL queries for a domain, for a subject matter. And I do that in that model. And then from there, when people pick items, it dynamically writes a SQL query and sends it off to whatever data source I have. So the users, the advanced users, you notice I have a connection between the semantic layer, the data warehouse, as well as the data lake. Because remember, these are the people that are high in openness. These are the people that are in R&D, and they are the data scientists. So I need to give them the ability to say, hey, I want to throw in some weather data. Let me toss that up into my S3 instance, and let's see how it plays out. Right? So these people need to have very open access to all layers. But when it gets to the ad hoc reporting, I can have them go straight through a semantic layer. And then the same is true for executive dashboards and metrics. So one of the things that I realized as we were talking about different BI tools one day is that because of this structure and because of this concept between openness and orderliness, a lot of BI tools really don't compete with each other. And they don't, in many cases, they don't even try to compete with each other. They might get asked to compete for the same business, but they're nowhere near each other's types of architecture. So if you look at, for example, QuickSight, Power BI, Tableau, they really are geared from ground up to focus on discovery. I'm going to find a new discovery. I'm not set with a schema that I have to use. I don't know what I have to use yet. Let me just pop this Excel spreadsheet in, or let me go acquire some weather data to add it in here. Let me just explore, right? And that the foundation of that is really from the concept of a data lake. The data warehouse, on the other hand, its focus is to at a mass level distribute information to people to help them run their processes. So companies like Looker and MicroStrategy and Business Objects, Cognos, OBIE, some of these are older names. Looker's probably the latest name in this type of business. But their idea is that, I'm going to provide this semantic layer that's going to give you structure for future queries, and I'm going to be issuing SQL queries to the database and then bringing it back. So here's how I would kind of outline it. If you see on the top, Amazon QuickSight, Tableau, those kinds of tools, Power BI, they're really running those discovery type queries, R&D. And then if you look at the semantic layer right here, this is where I would put Looker and have Looker run that semantic layer and deliver to large quantities of people. The focus really is, how do I provide this balance, right? How do I deliver to mass quantities of people, but also deliver to openness? And the process that we go through here is we still have the awareness capabilities. So you're creating still your data lake, and you still have people with the freedom to be able to explore and to define data. But when it comes to saying we need to conform some data, we still have our data warehouse. Now, how do we keep the data warehouse from being stale and not letting new information in? Well, we take the new information that we gather here that needs to be distributed out to the masses, the discoveries, if you will, and we codify those into the data warehouse. We bring those into the conformity of the data warehouse so everybody else can leverage the new discovery that we've made in our data lake. So Intricity, this is a lot of what Intricity is doing day in and day out, is we are helping organizations come up with this kind of architecture that will help them build out their organization. So this is how we typically start, is we'll conduct a series of interviews within an organization, get an understanding of what the culture of the company is, and then really diving into what their technology landscape is, and then designing that in a logical solution architecture that we can help them phase into their organization. And it has technology involved in it, et cetera. You'll see also on the right-hand side, we put a legend to it so that the organization can identify the justification for the components that have been suggested in the landscape. And really, that's it. That's what I had to present for you folks today. Is the concept between orderliness and openness, and the fact that the data lake and the data warehouse are not competitors to each other, but rather part of a landscape to work together. So I wanted to leave you with that. I've got my contact information on there if you guys have questions, but I'm happy to ask or answer some questions here as well. So Dimitri, I don't know if you want to take it from here.
Thank you, Jared. It was awesome, especially I think for the folks who concerned about what's data warehouse and what's different with data lake. And usually the best way to ask the questions is look to the chat. And right now, okay. I don't see any questions here.
Okay.
But maybe, and people can also speak up about this. And I have one question to you. Okay, we saw the picture with over the time it was data warehouse, then Hadoop, then data lake, then cloud. What do you think will be the next step in this line?
That's a good question. I mean, I think machine learning is the thing that's going to be, and it already is, but I think we're going to see a meaningful link between machine learning and BI that isn't here yet. Something that is actually the bridge between machine learning and BI, that either acts as an intermediary or adds information at the BI layer. Of course, predictive analytics are there and whatnot, but when we're talking about AI, we're really trying to get prescriptive. We're really trying to get to sort of the next stage of taking action and things of that nature. I also think that there's probably, along the lines of AI, the combination of the AI actually understanding what the BI is, and then being able to interpret almost in conversation what exactly is being requested, and then intervene with a potential answer, right? So maybe it's a Slack channel, and it's listening to the Slack channel, and people are saying, well, these numbers don't make sense. What is the actual commission that this sales rep is owed based on X, Y, and Z? That could be picked up by the BI layer, ran by AI, and then delivered to that audience. One thing that's really popular right now also is data catalogs. Data catalogs have been very popular, and partially this is because the data lake has sort of, a lot of organizations have sort of bought into the data lake hook, line, and sinker, and they're looking for something to categorize the data. The problem is that then they'll find this eventually, is that it still isn't conforming the data. And once they come to the realization that they still need to conform, then the data catalog is still very valuable, because what it does is say, if you want trusted data, here's where you're going to find it. This source has 5 stars or whatever. So yeah, that's kind of my thoughts on where things might be going. But I am not a prognosticator of the future. In fact, I subscribe to the Nassim Taleb, the future is unknown.
Okay, thank you. Can you open the chat box? Probably it should be from the right side. It's like you can open sidebar.
How do you make the semantic layer portable between vendors? That's a good question. So the question is, how do I take this semantic layer? I'll move up that slide.
Jared, I think you skip 2 questions if you scroll a bit up.
Oh, I did? I'm sorry. I just saw +1 and then that was What's the question? I don't see it.
I think the first question, can you talk in more detail about the semantic layer? And the second question,
yes.
Can you clarify what does mean semantic layer?
So a semantic layer, think of it as this. Let me go into Looker's example here. Looker created a language called LookML, and the purpose of the language is to allow you to define data elements and their linkages, and how they're interconnected, and how you want to name them for business users to use. Right. So that's what Looker's functionality does, and then what it exposes using the LookML, what it exposes to business users is the titles that you have specified for the data elements. And when they select those titles, so let's say it's, salesperson, revenue, et cetera, as they add those titles, which may just be columns in a normal data set, as they add those, what's happening on the back end in Looker is it's assembling a SQL query via the LookML. So it's actually creating a SQL query. Now, so no data has moved. Nothing has moved yet. No data has been put in memory. Nothing like that has happened yet. So once the person says run, Okay, I've selected all the data objects I want. When they hit run, that SQL query that's been dynamically generated based on the objects that the user selected, it goes and processes that SQL on the data warehouse. And now it doesn't have to be a data warehouse. Let me just say, when people create these things without a data warehouse or without some kind of conformity, the SQL queries are gnarly. I mean, and it's a lot of work to create the LookML because you've got a lot of unconformed data there. And so data modeling really does matter. Now the BI vendor, even Looker themselves, they won't tell you that. They'll say, nah, you don't have to use a data warehouse. But I think they've started to step that back as people have deployed these their technology, and found themselves in a bit of a mess. Either the queries take too long to run, or they find it hard to manage the LookML, those kinds of things. So but in conjunction with the data warehouse, it's truly phenomenal. It's an excellent tool to use because the query goes to the data and not the data to the query. So what comes back to Looker is just a final data set for the visualization itself. Nothing else moves. So it's very quiet over the network. So a semantic layer is not new, a BI semantic layer. A BI semantic layer came out, was issued by Business Objects, which was later acquired by SAP. So Business Objects came out many years ago, and the semantic layer they created was called the Business Objects Universe. And again, it's just a virtual layer that you create that defines the relationships in data objects in a database, so that the engine can generate a SQL query appropriate for the data set to be analyzed. Let me catch the next question. Well, I guess I should ask if that answers the question.
The next question, how to make the semantic layer portable between vendors? I think it's good to continue with your previous answer.
Yeah, this is a very good question. This is partially why I push as much logic down to the data warehouse as possible. So I don't have the semantic layer, chock full of logic for joining data and doing all of the heavy lifting. So there is a way to do it. There's a company out there called Composite. Composite is it's a tool that is a generic semantic layer. But Composite has sort of gotten into the business of saying, okay, we're not just going to be the semantic layer. We're going to be the semantic layer plus all of this in-memory stuff. So that all of the work you did in your data warehouse is going to be essentially replicated in memory in Composite. So I ding them for that because I feel like the big practice that you want to try to avoid doing in data warehousing and data architectures is moving the data, especially over the cloud. You want the cloud to be as hush-hush as possible. I want to move as little data as possible. And so anytime a BI vendor says, well, just put it in memory or have an in-memory data store, to me that says, okay, on the data modeling side, we've been a little lazy, and thus our data warehouse isn't performing appropriately enough to deliver the analytics fast enough for our users. Whenever you have to say, I have to put everything in RAM or put everything in memory, that to me is an indicator that there's potentially some poor design decisions on behalf of the database architect for the data warehouse. And so the answer to doing that, or the answer to portability, is to focus on putting the logic in the data warehouse and not in the BI layer. So the BI layer, ideally, in the end, is only issuing basic SQL, even though I've got the semantic layer. The reason that I want it, the reason I want the semantic layer, even if all of the logic is in the data warehouse, I still want a semantic layer for this reason. Number one, or two reasons. Number one, I want the queries to be very lightweight, very small SQL queries, very simple. Number two, take your projection 5 years down the road. Okay, you've owned the BI tool for 5 years, and let's say you have 10,000 users. Okay, and let's just say, for theory, you have 10,000 reports or 50,000 reports, whatever the amount is. Now, let's say that we have a change in how we maybe compute something. Or maybe we have a change in basic logic that you do have in the or that you would put in at the visualization layer. The last place you want that to live is in a tightly coupled visualization. If I've got my logic embedded in a single visualization, nested in each individual visualization of the 10,000 that exist, then I've got to open each one individually and edit each one of those. But if I'm using a semantic layer, I can open that one piece of logic once in the semantic layer, and every report that uses that semantic object is updated automatically. So it provides some control over the content that I've got out in the user community from a central location without putting the data in memory. Let's see. In your experience, time-wise, let me just make sure that I'm answering all the questions. I think I answered
Yeah,
that
this is the right question.
In your experience, time-wise, how many times more does it take to set up a data warehouse versus data lake? Data lake is easy. Data lake is very, very easy. The biggest expense that you're going to have in the data lake is not necessarily in the data lake itself, or at least it shouldn't be. It's in the actual connections and orchestrations of all of the source systems to land in the data lake. And that's getting simpler as well. But if you take the data lake at face value on what it really is, a face value, and what it was originally proposed for, you know, a lot of people started looking at the data lake as, well, okay, I'm going to deploy the data lake and everybody's going to use it for analytics. Well, here's the problem, is the moment you really want analytics out of it, you're going to be sort of pseudo creating a data warehouse, because you've got to start conforming data somehow. And so we just got out of a bank, a very large bank, and they had deployed a data lake, and it turned out they had like 5 Hadoop deployments, because they were trying to replicate the simple conformity that you see in a data warehouse, but still using Hadoop as the mechanism to deploy it. The simplicity of the concept of creating a schema that is designed for the logic but shoehorning it into a Hadoop deployment was really where they kind of went off the reservation. If you really use the data lake as, this is my place where I can easily land new data, I don't have any gatekeeping measures to keep the data from loading. If you use it for that purpose, that's a very easy environment to create. The data warehouse, on the other hand, is far more complex, because I have to have a relationship with the business to understand what is the logic that they actually want. How should I organize this data so that it conforms the way they will use it? And one of the things we've realized is that if you approach the data warehouse from a bottom-up architecture, where you say, here's all my data down here, all of this stuff, and I'm just going to create, sort of emerge a data warehouse out of all this data that's sitting down here in the data lake, those are overwhelming failures. Almost every time I've seen those occur, they are utter failures, and business users don't use it. But if you work with the business really closely and you help them kind of come to a determination of what are the, I like to call them Lego blocks of data. If I was going to create some Lego blocks of data for you, for example, date time. You want date time in almost every report, right? Yes. Okay, we're going to really deal with the date-time dimension. And we're going to really understand how you use date and time. What's the next one? Okay, it's customer. I want to know, and we really get into that and understand how they're using customer and how they're analyzing their customers' needs. That's where you start to get into, really understanding how you're going to conform the data. And it takes a heck of a lot more effort to do that. Because now when you start conforming it, you're going to invest in that process of conformity in a real way. But guess what? The investment that you put in that is not locked in a BI tool. You're not dead-ended. So that's why the investment makes so much sense. Because now the BI layer is decoration. I can put any BI layer on it, and the amount of logic that's sitting at my BI level is very minimal. Let's see. What tools do you suggest for for the definition of metadata documentation for the data lake? So the tools that are in the market today for doing this, they're called data catalogs, and there's a whole bunch out there. Amazon Glue does this. Elation is one that has become very, very popular these days because they kind of treat it like a Yelp, and they've got some great ideas on how to deal with data catalogs. One of the challenges data catalogs have had traditionally in the past is that it was sort of like a blank slate. You deployed it and there was no information in there, and you're just sort of relying that people are going to be manually entering data in, like this giant data entry thing on how to describe data elements, and they never worked. So what Elation has done is they've applied a lot of automation to that process and really started to do some query analytics. How many times are people hitting these tables, et cetera? So they've really gotten into a lot of the automation necessary to jumpstart that tribalism. I'm releasing a video. It should be out in probably 3 or 4 weeks on data catalogs. So you'll see that come out. Another one that's known is the Informatica. They changed the name. I think it's Informatica Data Catalog now. So that was the first question. 2 for the data. Oh, it moved on me. What tools do you suggest for the data warehouse? So I've become a huge fan of Snowflake. They are really, in fact, this is my humble opinion, but Amazon should be on the acquisition path to buying Snowflake. They have made data warehousing exciting again. It's sub-second billing. They don't move the data. It's sharded metadata that goes and accesses an S3 bucket. It's a very, for lack of a better term, sexy architecture for dealing with data warehousing. So very powerful. We've traditionally been a Redshift shop. We've done a lot of Redshift work, but recently I would take a serious look at Snowflake because it is definitely a game changer. For the entire BI solution, aka the data catalog business glossary, I kind of talked about that. That's the Elation types. Default is Excel spreadsheet, but it means manual. Can you recommend any? Yeah, so I think I've answered that question. Good chunk of time is spent on customizing visualizations. How can we abstract this so that it is easily portable across different visualization vendors? Think QuickSight versus Tableau. Yep, I hear you there. Assume 100% of querying logic is done at the source. I know exactly what you're talking about. You're talking about the formatting logic and all of that content and stuff. And unfortunately, there's not a really elegant way of doing that yet. And part of the reason why is the logic layer is the secret sauce to every BI tool. So if you could imagine the BI tools themselves, they kind of don't want this to happen, right? They don't want their secret sauce on how visualizations get generated and how that works, because they don't want what you're asking for essentially. The one way to potentially do it, well, you're still not going to get the formatting logic. So there's no simple answer there. But I definitely know what you're getting at, and it is a frustration. It's just that the vendors themselves wouldn't play ball with something like that. Have you tried Matillion?
Okay.
Yeah, I just see one more. Do you try Matillion for Redshift and stuff like? Yes. What I find with Matillion, they've got a very good layer for transformation and dealing with transformations in the cloud. Where I wish I could kind of, I feel like pushing them to a shotgun wedding between Matillion and Illuma, or Matillion and Fivetran, one of those two, because what they don't do very well is deal with the orchestration of on-premise data to the cloud and keeping that streaming data to the cloud. So they do the T and L really well, or the L and T really well. So they deal with the transformation processes super well, but the orchestration of the data, the L and ETL, they don't really do a great job of loading data if it's not in S3 yet. So but I do love Matillion. It's a great tool, great for dealing with if you're not super savvy with writing SQL, then Matillion is definitely a good way to go, and it's a good way to keep all of your stuff organized, so you're not having to do a giant learning curve between team members. Should we deploy ML on the semantic layer instead of the BI layer? I would say so, yes, because the machine learning at the semantic layer would allow me then to, well, at least hopefully, query that outside of the BI layer having to be involved. So, and so this is just a plea for openness, really. If I had a semantic layer, if I'm at the semantic layer level and not tightly coupled to a visualization, that means that the ML, the visualization layer will be a byproduct of having the ML as part of the as part of the semantic layer. But if I had an open semantic layer that people could feed from, assuming this existed, if you had an open semantic layer that people could feed from, I would definitely want the ML layer to be there. And I think that is all of them.
Yes, that's all, Jared. Thank you very much. It was awesome, interesting conversation, and we got lots of time to go through the questions. Most of them really good. I will wait presentation from you, because I will upload video and slides to our broadcast and share with the audience. And I think it's all people. Yeah, thank you for your time.
You bet. Thank you. Take care.